Here we're going to talk about what's called solving rational equations. And what I'd like you to first do is please review the video Finding the LCD of Rational Expressions. That's really the key to this section, okay? So you want to make sure you have this dialed before we jump into what we're going to do now. So assuming that you've done that and you're feeling pretty good about it, let's go ahead and take an example. Okay, so this is an example of a rational equation. Do you see, first of all, why we call it an equation? Because it has an equality sign. Now, it's called a rational equation because you have you have a rational expression, one or more rational expressions. So basically, remember, rational expressions are sort of just like complicated fractions. So the first thing I'd like you to do in these problems is, you see how it's all in the same line? And this seems like a small point, but I would like you to take the whole equation and write it on the line below so you have a little bit of space to work, okay? So let me do that now. I'm going to write x plus 7 divided by x plus 2 plus 1 over x squared minus 3x minus 10 is equal to 1. So now I have a little bit of space to work with. Okay, so the first step we're going to do is we're going to clear these fractions. And so to do that, we have to find an LCD. So to find an LCD, what you do is you take the denominators, so you take x plus 2, and you also take the other denominator, x squared minus 3x minus 10, and you factor those. So x plus 2 is a prime polynomial, so it's just going to remain x plus 2. And x squared minus 3x minus 10, that can be factored as x minus 5 multiplied by x plus 2. Now when you do that, remember the whole point is to find the LCD. And the way we do that is we compare the factors. So I see one factor of x plus 2 and one factor of x plus 2. So recall, I just take one factor of x plus 2. And then I see one factor of x minus 5, and I've got to put that in there as well. Now, of course, this is the step that I asked you to review in the previous video. So if you're having trouble with any of this, make sure you go ahead and review that now. Okay, so what we do now is we take that LCD, this, and we multiply both sides of the equation. See the equality sign right here? So all of this is the left-hand side. So first put a big set of parentheses around that left-hand side, and then put a big set around the right-hand side. And then you take the LCD and you put it first on the left and then on the right. So out here I'm going to put x plus 2 times x minus 5. That's for the left. And then same thing for the right. X plus 2 times x minus 5. And that's why I wanted you to write it on another line so that you had some space to work on the left and on the right. If I would have done it here, it would have been really cramped and it would have ran into the word solve, and it would have made my life a little bit confusing. Okay, so I do it this way for clarity. Okay, now, do you see how it's addition right here on the left-hand side? Well, I have a sum, and whenever you're multiplying something that is all of this by a sum, you have to take this and distribute it. So I'm going to take this, I'm first going to multiply it by the first term, and then I'm going to take that and multiply it by the second term. Okay, and I'm doing that because it's addition. Whenever it's addition or subtraction, you have to do that. Now, when you do that, remember, this is the LCD, right? So the LCD is over here, and the point of the LCD is that, if I think of it over 1, the point is that these denominators by design are going to go evenly into this. So I'll be able to cancel the denominators with something here. So you can see what's going to happen. When I first multiply these together, do you see how the x plus 2 is going to cancel with the x plus 2? And when I do that, what's going to be left is the x minus 5 here multiplied by the x plus 7. So let's write that down. I'm first going to get x minus 5 times x plus 7. And that was the result of multiplying these two together. The x plus 2's cancel. Now remember, we also have to do this, right? This long arrow. And when you do that, now you're multiplying this fraction once again, this rational expression, by this one. And of course, this right here is going to go evenly into that. But remember, x squared minus 3x minus 10 is really just this in disguise, x minus 5 times x plus 2. So this is the x minus 5 times x plus 2, and that's going to completely cancel with that. And when I do that, I'm going to have just the 1 remaining. So I'm going to have plus right in the middle right there, the 1 that I get when I multiply this rational expression by that rational expression. And now I'm looking at the right-hand side, right? Equals, well, 1, we don't have to worry about that when you're multiplying by something. And then I'm going to have the product of these two. Let me just write that down. X plus 2 multiplied by x minus 5. Okay, now I'm going to solve this equation, now I'm going to multiply out. Now, notice at this stage how the fractions have been totally cleared. That was the whole point of the LCD. Okay, so multiplying out x times x, we're going to get x squared. And then I'm going to get plus 7x minus 5x minus 35. And then plus 1, don't forget that right there. And on the right-hand side, it's going to be x squared minus 5x plus 2x minus 10. And now I combine like terms on the left. So I've got x squared plus 2x minus 34 is equal to x squared minus 3x minus 10. And now I'm going to subtract x squared from both sides. Let me rewrite that so you can see it. I'm subtracting x squared from both sides here. So let's see. And let's see, what am I left with now? Well, it's going to be on the left-hand side, 2x minus 34. And on the right-hand side, I've got, well, just negative 3x minus 10. And now I'm going to add 3x to both sides. And so now I'm looking at, let's see, it's going to be 5x minus 34 equals negative 10. Let's add 34 to both sides. And what does that give me? Well, I'm still going to have a 5x on the left-hand side, and the right-hand side, it's going to be 34 take away 10, which is 24. And now I'm going to divide both sides by 5. So I'm going to get, let's see, x is equal to 24 over 5. Now, so this would be my answer, but there's one thing to be aware of when you're solving a rational equation. Do you see how the denominator's here? Do you see how there's an x plus 2 in the original, in the denominator? Now, if x was negative 2, right, if there was a negative 2 right here, negative 2 plus 2 would be 0, and this rational expression would be undefined. So I got kind of lucky here that this was not negative 2, because if it was negative 2, it wouldn't be a solution because it would have caused one of the expressions to be undefined. And likewise, what would have caused this to be undefined? Well, remember, this was just x minus 5 times x plus 2. So basically, for this, x could not be negative 2 or positive 5, because those would have caused this denominator to be 0. So basically, what happens is whenever you get an answer here at the end, you have to make sure that when you plug it back in for x, these expressions are not, the denominators are not 0, because that would cause the expressions to be undefined, and this would not be a solution. In this case, it's fine. It is a solution. Okay? But we'll see an example in a moment where that's a problem. Okay, let's take another one now. Okay, so we're going to solve 5 over x minus 2 equals 5 over x minus 2 plus 3. Okay, so like I encouraged you to do last time, rewrite the original problem. So it's going to be 5 over x minus 2 is equal to 5 over x minus 2 plus 3. Okay, now you find the LCD. Now the LCD is obvious in this case because, you know, this is like a 3 over 1 here, so the only denominator I see is x minus 2. Okay, so the LCD, let me write that down so we can see it at least. The LCD is just equal to x minus 2. Okay, so what I'm going to do now is take that LCD, and remember, we're going to put parentheses around the left and parentheses around the right. That is the entire right, okay? Not just this little part over here, but the entire right-hand side. And then you put your LCD. Now, the LCD is subtraction, so you have to make sure you put that in parentheses. If you don't, everybody's going to think you just have negative 2 times this. You don't want that. You want all of x minus 2 by that, And likewise, all of x minus 2 on the right-hand side. Okay, now on the left-hand side, well, this is, x minus 2 over 1. So the x minus 2's cancel, and we get just 5. That's nice. And on the right-hand side, it's a sum. Do you see that? So remember, you're going to have to take the x minus 2 and distribute it. So boom, boom. It's going to get multiplied by both of those. Now, when you multiply it by this one, remember, this is x minus 2 over 1. Those x minus 2's are going to cancel. And you're just going to have that 5 there. So it's going to be 5, and then plus, don't forget that, 3 multiplied by the x minus 2. Okay, let's go ahead and solve that. 5 is equal to 5 plus 3x minus 6. And combine like terms on the right. So 5 is equal to, well, it's going to be 3x minus 1. And now if I add 1 to both sides to get x by itself, I've got, let's see, it's going to be on the left, it's going to be 6. And on the right, it's going to be 3x. And now divide both sides by 3. And I've got x is equal to 2. Now, before you circle that, we have to remember what we talked about with rational expressions. You have to make sure that the number that you get at the end doesn't cause any of the original expressions to be undefined. And I can see here that if you take a 2 and you plug it in, 2 minus 2 is 0 in the denominator. So in fact, I have one of the expressions undefined. Well, in fact, 2 causes both of these to be undefined. But anytime a number causes one or more to be undefined, this cannot possibly be a solution. In fact, this is what we call an extraneous solution. Extraneous solution. Okay? An extraneous solution is not a solution. It's our way of saying, hey, it's something you found at the end, but it doesn't satisfy the original. Okay? So now this was the only candidate, and that didn't work out. It was extraneous. And so this problem would have no solution at all. Now, as it happens, sometimes you have extraneous solutions, and other times you still have numbers that truly are solutions. Okay? So you always have to exclude your extraneous solutions, and after you've excluded those, the question is, what do you have left? And if you have anything, that would be a solution. If not, you simply have no solution. Okay, let's go ahead and try one more because these are kind of complicated. And now we kind of know the strategies involved. Okay, we're going to solve 3 over x plus 2 minus 4 over x equals negative 3. Okay, so what we like to do is rewrite the problem, right? So it's going to be 3 over x plus 2 minus 4 over x is equal to negative 3. And once again, we start with finding an LCD. So to do that, you take the denominators, x plus 2 and x, and you find their prime factorization. Now, x plus 2, that can't be factored, right? That's a prime polynomial, so you just go ahead and bring it down. Same with x. It's prime. It can't be factored any further. Now, to build the LCD, what you do is you start with the factors, right? Or, the lowest factor that you see. So first I'm going to start with an x. Now, this has one factor of x, and this is kind of a tricky one, which is why I wanted to do this problem with you, actually. How many factors of x does this have? The answer is 0. Why? Because when we say the word factor, we mean x is being multiplied by something, but x is not being multiplied by 2. X is being added to 2, okay? So this has no factors of x. So to recap, one factor of x, no factor of x, no factors of x. So you simply put in one factor of x from this one. And then you move on to factors of x plus 2. One factor of x plus 2, no factors of x plus 2. So you've got to put in one factor of x plus 2. This is a really important example. Make sure you understand why the LCD is x multiplied by x plus 2. This does not count as a factor of x because the word factor implies multiplication, which this is not. Okay, now you take the LCD and you multiply both sides of the original by that LCD, right? So big sets of parentheses for the left, and then an x times x plus 2. And then the exact same thing for the entire right-hand side, right? X times x plus 2. Okay, and then remember, this is like over 1, and you see how it's subtraction here? That means you've got to take this and you've got to distribute it. once, twice. Now when you multiply these two together, the x plus 2's are going to cancel, and you're going to have just 3 multiplied by that x. So it's going to be 3x. And then ready for the next one? Minus. Do you see what's going to cancel when you multiply this by that? It's going to be the x's. And x down here is going to cancel with that x right there. But you're still going to have the x plus 2, and you've got to multiply that by the 4 that's still there. So it's going to be 4 times x plus 2. And on the right-hand side, well, let's multiply the 3 and the x together. So it's going to be a negative 3x times x plus 2. Now you might be wondering, hey, why didn't you take the x plus 2 and multiply it by the negative 3 and then multiply it by the x? The reason is because, do you see how it's multiplication right here? You only distribute when it's addition or subtraction like it was over here. So in this case, the x plus 2 does not get multiplied by both of these. It's all multiplication, so the x plus 2 just gets multiplied once. It doesn't go twice like it did when you have addition or subtraction. Okay, so now we're going to take the negative 4 and distribute it on the left, and we're also going to take the negative 3x and distribute it on the right. So it's going to be 3x minus 4x minus 8, right, distributing the negative 4, is equal to negative 3x squared minus 6x. Combine like terms on the left, so we're looking at negative x minus 8 is equal to negative 3x squared minus 6x. Now, this is quadratic, that is, it's raised to the second power. Whenever you have a quadratic equation, or anything higher than just linear, you always want to get 0 on one side. So I want to keep this coefficient positive, so I'm going to, right now it's a negative 3, so I'm going to add, eventually, I'm going to bring everything over to the left, we say, okay? So, but technically what's happening is this. I'm going to add a 3x squared, first of all, to both sides. And what that looks like is this. It's going to be 3x squared, right, minus x minus 8, and then I'm left with a negative 6x there. But now I want to remember, I'm trying to get 0 on the right-hand side. So now I'm going to add 6x to both sides. And now I can combine like terms on the left. So I'm looking at 3x squared plus 5x minus 8 is equal to 0. Okay, so we have to solve this equation, right? So let's go ahead and create a little space for ourselves here. Okay, let's write that up here. 3x squared plus 5x minus 8 equals 0. Okay, so the way we do this is we have to factor this left-hand side. So remember, you take the 3 and you multiply it by negative 8, and that gives you negative 24. And you have to find two numbers that multiply to be negative 24, but add to be positive 5. So let's see, negative 1 and 24, no, these add to be 23. Negative 2 and 12, no. Negative 3 and positive 8. These work, right? They add to be positive 5. So you take those two numbers and you replace the 5x with negative 3x plus 8x. So it's going to be 3x squared minus 3x plus 8x, and don't forget minus 8 is equal to 0. So now we're going to factor by grouping. So it's going to be the first two, right? We group. It's going to be 3x times x minus 1 plus, and then you group the next two. So 8 times x minus 1 equals 0. Now from these two, you can factor out x minus 1, and you're left with x minus 1 times, well, it's going to be 3x plus 8, and then that's still equal to 0. Finally, you set each of these equal to 0, and you get x is equal to 1. That's from this. And then from the next one, it's going to be x is equal to negative 8 over 3. You get that when you set this equal to 0. Now, before we box these and celebrate, remember, you have to make sure they don't cause these denominators up here to be 0. And neither of them do, right? These denominators are 0. Well, this one is 0 when x is negative 2. And this one is 0 when x is 0. And neither of those numbers are right here. So these indeed are our two solutions. Okay, so solving rational equations is kind of involved, right? And you have to really make sure you know how to find the LCD and you're comfortable distributing. Okay, and after that, you may have to solve a quadratic equation, but these are all things we know how to do. Okay, until next time.